In this video, I am going to be talking about forward list, which is a container of C++. Forward list, like stdlist, is a templated class which manages an array in non-contiguous memory space, dynamic memory space, while stdlist is implemented as doubly linked list. Forward list is implemented as a singly linked list, which means you can iterate from one int to the another int, but you cannot iterate in the reverse order. Understandably, forward list is less complex in its implementation than stdlist, which is in effect a trade-off with the flexibility of the list to iterate in both directions. Copy and move operations are allowed. You can copy construct, you can copy assign, move construct, move assign the objects of forward list. Insertion and removal of elements is fast, but it does not allow random access. Let me explain it directly through the code. To create a list, you need to include the library. To create the forward list, you need to include the library forward list. And with this inclusion, you can create the list using the syntax which is similar to the syntax to create a vector or list or other DQ containers. The syntax is you need to specify the namespace, scope resolution operator, and the name of the class, and you specify the type you want to instantiate the class for, and the name of the container or object, name of the object. Now you can insert the data into it, but there is a function that you can use to assign the data. I want to set data 1, 2, 3 into the list, and I can display it. So this should display the list data. Let me show you in the output screen. So I want to compile the code. It is in the main1.cpp file, and execution. So it is displaying the data 1, 2, 3. Now back to the coding. In addition to instead of displaying in this function, I would like to create a function specialized for displaying. So let me create a print function. I want to pass, let's say, const the type of the object, right, and object let me just put that thing here, the code that I used to display, and it's going to be obj element and object, and yeah, I think let me keep it like this, simple. Next, you can access the front element, the element on the at front, using by calling the function. and you can you can use a clear function to clear the list. You can use empty function to display whether it's empty or not. Maybe I should use I should display those things, that information in this space. And here we cannot push from other side. We can only push from the front side. So let me first display the list information here. Then if I attempt to push from the front side, back side, it would be a problem. So push. If I want to insert the element, I could use in other containers, use this function 56 and print. So let me quickly compile and see what would be the output of this code. So now it is complaining it does not have the member named pushback. That means pushback is not allowed in for list because it is one directional. So there is one direction, so you can only push from the front. So you push from front, it will be pushed on the front side, and you can push another element 66, and then after that we can compile and display the output. So now we have these things here displayed. Initially it was empty, and then now it's not empty. The data pushed into it is 66, 50, 66, 56. Right. So now initially it was assigned 1 2 3, but it was clear, so it didn't display. If I display at this point, it should display the data 1 2 3 here. Let me try it again. So now you can see 1 2 3 displayed data, and then it was cleared and then pushed front. 56 was pushed on the front, and after that 66 was pushed on the front. If push back was enabled, the push data would appear on this side, 56 followed by 66, but it is push front, so it is pushing, it will push on the front side. Now this is the one of the feature of the for list. The function insert and erase is allowed. You can insert the data like in the list. For example, if I want to insert, let me include a few more elements so that insertion and erasing operations would be it would be easy for me to explain it. Push front, let's say 77, 88. Now if I want to now let me display that data here. It will obviously display 88 followed by 77 and 66 and 56. If I want to insert an item, let's say I want to insert 111 after let's say 77, in between 77 and 66, then what I would do is I would get an iterator to the first element, by calling the function ifl, and I would increment it one time, two time, plus 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 plus, and I will pass these things as arguments to the function invocation insert after. Right, so it should insert after the after this element, right? So this this iterator will be pointing to first, second, and this 66, right? So let me see what output does this give. Print so in the compilation screen, I think there was a typo issue. Should ifl. Yeah. So now it was inserted after this element. So first iterator begin function will return iterator pointing to this 88, and then plus plus will point to be iterator, the iterator obtained after incrementing it will point to this element, and the second increment will point to this element, and it will insert after this element, right? Now again, you can also erase the data by calling the erase after function by following, but you don't need to pass the data because you are just removing the element, but you can just follow this process. Now you can see that element has been erased. The element after this 66 has been erased. This also allows copy construction. For example, if I want to create a new object by copying from the existing object ifl, I want to create a new object with the name ifl2 by copying from ifl. Then now print ifl, print ifl2. So this ifl2 is created by copy constructing from the ifl1 object. It will have its own copy of the elements, but the data would be copied from the existing object. Let me explain it a little bit. So to create a copy constructed version of the object, or to create new object by copy constructing from existing object, this is syntax. So if this is an object, then it will invoke the copy constructor, and ifl2 is going to be the name of the new object created. ifl1 is the source object, or the existing object, right? So now when I display, it will display the data that belongs to the source object, and this line will display the data belonging to the next object, or newly created object. Let me show you the output. So now you can see this was the copy constructed object data, and this was the source object data. Similarly, it also allows a copy assignment. For example, if I have another object created, IFL3, and if you copy assign it to equals to IFL1, so you can display IFL1, IFL, it should be, yeah, only IFL, and then you can display IFL3, right? So the last displayed data would be, in this case, the copy assigned version. So this statement actually calls the copy assignment operation. So the data displayed on the last and second last would be copy assigned version and the source version data. So you have this data was copy assigned version and this was the source version data. And it also supports move construction and move assignment. So if I want to create a new object through move construction, let me give the name IFL4 in this case, and for move construction I need to pass R value reference to the object. So the way of doing that is calling the function move. Now it would display, let me display, see the output, and I'll explain it further. So these two lines will display the source data and the target data or newly created object data. Let me compile and see the output. So now you can see in this place it is empty. So the source version data is not displayed. So only target object has the data. That means the data was moved. When creating a new object, the data was moved from the source object. So source object does not contain data anymore. And now the data is with the, or resource is with the target or newly created object. Similarly, you can also move assign. If I have, let's say, another object created, let's say I have IFL5 and I assign some data to it, IFL5, one, 1, 2, 2, 3, 3. If I have 3 data and I would like to copy assign IFL5 equals to IFL2. But if you want to invoke copy assignment, you need to pass the R value reference. So the way of doing it is call this move function. So now after this I would like to see the IFL2 data, because it was displayed, it was it had a data, so it was displayed. Now I want to see it again because data is actually to be moved from this this object and 5 object. And also before I also like to print the IFL5 object data before the move assignment. So let me see the output in this case. So we can see the data was data in IFL this 5 was this 11, 22, 33, which was assigned to it. Now after move assignment, the source object does not have data, but the IFL5 object actually acquired the resource or data that actually belong to IFL2. it was a move operation, right? That was about the some of the additional features, particularly inserting or erasing the element in the forward list, and move construction, move assignment, copy construction, copy assignment. Now next I am going to talk demonstrate the fact that the why it is actually different from list, right? It is different from list because to demonstrate that, I want to make this function more generic so that I can use both forward list and list to print. I can use this function to print both list and forward list objects. So let me make it a template, right? So the type, everything, I'm going to be using T. Yeah. Okay. So this will accept both list and forward list. So now let me have something like this, 4 5 6 assigned to it, and let me just print this thing, the data, and like in the list, I should be able to access the element through iterator. Let me try to access it, ifl dot first iterator, and then I can increment it plus 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 plus, I mean second, third, fourth element. Begin will give you access to the first element, now it's going to be fourth element. So I want to insert this into the output stream. So this is about inserting to the output stream. I want to remove everything else. Let me clean this up so that it looks more tidy. So now I am able to access. Let me demonstrate it, and then I will discuss it further. So now you can see the fourth element has been accessed through the iterator. First, second, third, fourth. Now in the case of list, you would now you are actually starting from the first element and you are iterating to the next and next and next element, but reverse iteration is not allowed in this case. This is only one directional list. So if I attempt to reverse this iterator, for example something like this, minus minus, it should be a problem. Okay, once you get an iterator pointing to one particular element, in this case this entire expression will be an iterator pointing to the fourth element, then you want to iterate back. I mean you want to point to the third element, right? And you decrement minus minus, and then you access the data. So in this case we are going to get into problem. So it says that this operator is not no match for the operator, right? So but with the same operator, if I use for the list instead of for list, let me change it to list. The only thing I have changed here is I have changed this library to the list and then the type to the list, right? Let me compile it. And it works, right? There's no problem here. So it is working. Right, so reverse iteration is not allowed, and likewise you have, you can also have reverse iterator. Reverse iterator for container can be obtained by calling the function called rbegin. Right, if you want to iterate in the reverse order from the last element to the first element, this is the thing to be used. So if I want to iterate in a for loop, equals to rbegin, it not equals to r end it plus plus. So now let me for instance use this begin. Okay, so I want to comment this out so that I don't get the same problem again. So if I start from begin and to the end and iterate, and I do compilation, because this is now this is a for list object, so expectation is that this code should work. Oh, there was a small problem. So we have to call this through the object ifl. So there is a small syntax problem. Semicolon missing here. So now it is working, right? The forward iterator is it allows forward iterator, but if I try to use the reverse iterator for iterating in the reverse direction, it will not allow, because that thing is not defined because of the nature of the list, a forward list. So now this has this class does not have this name rbegin, right? But if we try this thing for the list, then it works, because the list is a two-way container, two-way list, linked list. List is implemented as a two-way linked list. So in this case it should be okay, but it will print the data in the reverse order from starting from 6 5 4 2 1. So now you can see the data displayed in the reverse order. Okay, this was all I wanted to talk in this video about for list. Thank you for watching.